We're going to talk about piecewise functions. First off, we're going to start by graphing two separate linear equations. We are going to graph them for different values of x. So this first one, y equals x minus 1, is only going to be graphed for values of x that are less than or equal to 0. In interval notation, that's negative infinity up to and including 0. Okay, let's graph that. So we're going to use the fact that it's a linear function, so that means the negative 1 is a y-intercept. So that is where x is equal to 0, and so we are going to graph it for x equal to 0, so we can put a point there, at point 0, negative 1. Now, we want to only now include values that are of x that are less than 0, so we're going to include points on this line that are to the left of the y-axis. We can use the slope of 1 to find other points. We can go, in this case, we're going to use that slope 1, and we're going to go down 1 and to the left 1. So we're going to kind of use the opposite of the up 1, down 1 that it might look like we want to use. Okay, but doing that, we get this line represented by x minus 1, but it's only valid for values of x less than or equal to 0. Now let's look at y equals negative x plus 2. Now we're going to just look at values of x that are strictly greater than 0. So interval notation, that's going from 0 but not including it to positive infinity. So if we look at the y-intercept of 2, that is not included. So we can put an open point there. Everything greater than 0 is included, so we'll put that open point there as a kind of a place to connect the next point to. So now the next point, if we use that slope of negative 1, we're going to go down 1 to the right 1. And we can find another point to the down 1 to the right 1. All right, we connect those points, and we get that. Okay, when we have two equations for two separate intervals of x and we combine them into a single function, that is what we call a piecewise function. So we'll call it f of x, but here we're going to have this brace, and it says that we are defining it as x minus 1 for x values that are less than or equal to 0, and we're defining it as negative x plus 2 for values of x that are greater than 0. Okay, so that is what a piecewise function is, a function that has basically two equations or more than two equations, and the equations that we choose are based on the values of x. All right, let's look at another example. Here we have our function is equal to 2x plus 1 if x is less than negative 1. It is equal to x squared if x is greater than or equal to negative 1. All right, so if we want, we can actually write that out as two separate equations. So the first one, 2x plus 1, so linear equation, and that's on the interval from negative infinity up to but not including negative 1. So if we go ahead and graph that, if we want to use the y-intercept of 1, okay, I'm going to put a little mark there, but it's not really included, right? Because that's where x is 0, and we only want to graph 2x plus 1 for values of x that are less than negative 1. So use the slope of 2. So the slope is 2, so if we want to go to the left, we need to go down 2 and to the left 1. Okay, now that point right there has x value of negative 1. It's not included for this equation for negative 1, so what we want to do there is we want to put an open point. Okay, now from that open point we can find another point. All right, we go down 2 to the left 1, and x is negative 2 there, so that's included in that interval, and then we'll go down 2 and to the left 1 to get another point. So we connect those, and there is that piece of the graph. Okay, so we have graphed that piece. Let's look at x squared. Now this is for x values that are in the interval, including 1 up to positive infinity. That should be -1 to positive infinity. All right, so hopefully we have an idea in our minds of what that x squared graph looks like. So we know if x is -1, then the function is +1. That's included at 0, 0, 1, 1, and 2, 4. All right, so this is the advantage of kind of having those toolkit functions memorized or be familiar with them. So there is the other piece of the function. So we have that graphed. Okay, we'll look at another example. Let's look at this one. We have got a linear equation, x plus 1, that is defined on the interval -infinity up to but not including -2. So we're going to start this one off with just plugging in x equal to -2. So now I know it's not included for this piece of the function, but we're going to put an open point there. So if we plug in a -2, the y value is a -1. So open point at -2, -1. That now gives us a place from which we can plot other points. So the slope for this line is 1. Okay, so we can write that as -1 over -1, which tells us to go down 1 and to the right 1, down 1 and to the right 1 to find other points. Okay, we connect those, and that gives us the graph of that first piece, x plus 1. Let's look at the next piece. Y equals -2x plus 3, and that's defined on the interval starting and equaling -2 to positive infinity. Now this interval includes 0, so we can plot the y-intercept of 3. The slope is -2, so we can first look at it as the -2 over 1, which tells us to go down 1 to the right 1, down 1 to the right 1. We want to go the other direction, and so if we put that negative in front of the 1, that's going to tell us to go up 2 to the right 1, up 2 to the right 1, and it's that point where x is equal to -2. So we don't want to go any more negative because it's only defined from x equal to -2. So we connect those points and we get that piece of the function. Okay, this next example, we're not going to actually graph the function, but we're going to evaluate at given values of x. So we have the function there, and we want to evaluate first at f of -3. So this is where x is -3. We want to pick out the piece of the function that we're going to use. Well, -3 is less than -2, so we're going to use y equal to x plus 2. So when we plug that in, we will replace the x with a -3, add 2, and we get the function value of -1. So that is the function evaluated at -3. All right, so now let's look at f of -1. Okay, so first we want to identify which piece of the function are we going to use. Well, -1 is greater than -2, so we're going to use -2x minus 4. So plugging -1 into x, we get -2 times -1 minus 4, so that's a 2 minus 4, and we get -2. All right, so f of -1 is equal to -2. All right, finally, we want f of 0. So that 0 is greater than -2, so we're again going to use the piece that says -2 minus 4. So -2 times 0 minus 4, 0 minus 4. So our evaluation is -4.